Video number four, confidence intervals. Here's some practice. I'm going to do some questions with you. I couldn't think of the word. Okay. You own an apple orchard. You cannot measure all of the apples in the orchard, of course. It would take you forever. But you need to know if they're big enough to sell at the market. So what you would do is you get a random sample. Maybe you would do a cluster. You would say, okay, I'm going to break up my apple trees into clusters and I'm going to just, use use the amount from this one tree or whatever. Here's the data. Find the margin of error in a 95% confidence interval for the population mean. Just in case you've forgotten the formula for confidence intervals, it's x bar plus or minus the margin of error, and the margin of error is our critical value times the standard error of the mean, which is sigma divided by n. What do we have here that we need? Well, we've got x bar is 86 grams. We've got the standard deviation of 6.2 grams, and we've got the n. What don't we have is our critical value for a 95% confidence interval. And what was that? For 95%, I think it is 1.96, but let's just check. Scrolling up, 1.96. What a memory. Z critical is equal to 1.960. Of course, you don't really need that zero there for our computation. And we have x bar is 86 plus or minus, let's see what that margin of error is, 1.960 multiplied by 6.2 divided by square root 46. And of course, that's still going to be 86 grams plus or minus. What's the margin of error? Figure it out. Did you figure it out? I got 1.79 grams. Now, I haven't been too on a stickler over the number of significant digits or the number of decimal places. Most of the stuff I'm going to do for you is multiple choice. So you're going to end up with some kind of idea of what I'm looking for in the final answer. Find the margin of error is 1.79 grams. 86 grams is our sample mean. Let's put that together as a different kind of confidence interval, and let's see with our mu is between 86 minus 1.79. I'm just going to 86 minus 1.79, and we're looking at 84.21 grams. So I'm assuming that's one apple, right? It would have to be. That makes sense. And let's see what we got there. No. This is a strange question. Or is it? Anyway, you know what? It's 9:53 and I'm getting tired. That's the problem. 86 plus 1. This is not the problem. The problem is me. And we got 87.79 grams. Well, that's our 95% confidence interval by hand. Not too bad. It's kind of easy to do by hand, but I am going to show you how to do it using an online calculator and using Excel. Aren't you happy about that? First thing I'm going to do is I'm going to use Excel. Here I've got the Excel spreadsheet. I put in the sample mean. X bar is 86. Population standard deviation of 6.2. The number in the sample is 46. It's so super easy to do confidence interval, sort of, equals. CO, oops, of course, equals in Excel, CONFID. Aha, look at that, Excel. Don't I love you? FIDENCE. Because we are dealing with the standard deviation, the population standard deviation, that's what I want. Other books, other people might say, you know, if the sample size is greater than this, I don't care about that. If we know the population standard deviation, we're going to use the normal distribution, which is dot NORM. Of course, we always need a bracket. It tells us we need alpha, standard deviation, and the size. Alpha. What the heck is alpha? We haven't done alpha before. I'm going to tell you what alpha is. If we're dealing with a 95% confidence interval, alpha is the 5%. You know, we could be 95%. We want to know alpha is kind of like that error. What amount of error do we have that we're going to live with is 5%. How do we write 5% as a decimal? 0.05, standard deviation. We can either click on the standard deviation here, or we could just type it in. I'm going to just click it here, comma, and what is the size of our sample? It's 46. Dun, 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 dun. 1 point, look at this, 1.791. It gives us all of it. The thing is, it says confidence. It doesn't give us the entire interval. It just gives us the margin of error. So I'm just going to write that here, MOE. Maybe I should have did the other way. What could I do now in Excel? Well, of course, I could add and subtract from the 86. How can I do that in Excel? I'm going to use a formula, equals 86 minus this. That gives me my low end. And then if I want to write down, I can write 2. And then I can do the high end. And the high end is going to be 86 plus the margin of error. Oops, I forgot my equals, didn't I? Whoops! Stop doing that. Crap. See, Excel. Sometimes Excel does drive me crazy. 86 goes here. Okay. There we go. That's better, Laura. Equals 86 plus the margin of error. And let's see if we got 84.21. Yay. And you know, with Excel, if I had it bigger, I could change my decimal places to 87.79. Easy as pie. You like that math joke? Easy as pie. Method number 1. Didn't take too long to do here. Excel, number 2. And number 3, we can use an online calculator. That gives us good results, but we also need to know how to interpret each part that it's giving us. I'm going to flick it over here. This is the one that I like. It's the social science statistics. It gives us calculators, information on descriptive statistics. There's tutorials. Which statistic test should you use? All kinds of nice stuff. And here's the website here. You could just Google it. Scroll down. Here's all, like, there's a whole bunch of tests. Of course, you're going to have to know all of those for your final exam. Joke. Let's keep scrolling down until we see, look at this, confidence intervals right here. There's a couple of different ones. We're going to want the Z. Remember, if we know sigma, if we know the population standard deviation, we're going to use Z. We're going to use this one, but we're going to use this first. Okay, click. It says, this simple confidence interval calculator uses a Z statistic, blah, 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 blah. Note, you should only use this calculator if your sample size is 30 or greater, and or you know the population standard deviation sigma, and use this instead of your sample standard deviation, an unusual situation. If your data does not meet these requirements, considering using the t statistics. So what I'm telling you, what do you need to have? Sigma. And here, look, they give you the formula. Aren't they lovely? Let's put in our information, the sample mean. You would think that I would have that remembered. Sample mean was 86. It's not that, it's 86. Sample size, how many apples? 46. How do you like them apples? And the standard deviation, don't worry that it says S. It's sigma, 6.2. Confidence level, what did we want? We wanted a 95%. Now, the only thing that's unfortunate about this one, it only gives you 80, 90, 95, and 99. But those are the most common ones anyway. And ding dong dong, calculate. Let's scroll down. It tells us this is how it sets it up. Mean is 86 and a 95% confidence interval 84.21. 84. Look at this. Aren't we smart? And then the upper limit is 87.79. You can be 95% confident that the population mean falls between those two numbers. Over here, let's just say I said, well, this part here doesn't give us the margin of error, did it? No. But over here, it says, okay, here's our critical value, 1.96, which we know. It does the calculation a little bit different here than divided by the square root. It does it a little bit different, but this gives us the standard error right here. And then it says, okay, well, we're going to put it here in between these two numbers. This is the margin of error, 1.79. Let's just do a double check, 1.79. Those are three really good options. Using your brain, using pencil, calculator. Second one, using Excel. And then the third one is using the online tool. What I'm going to do is just stop my video, and I'll do these other examples after. But what I think you should do is to try them on your own. Okay? All right.